In order for all those resources to work, we need to store them somewhere. Renewable technologies such as solar PV and wind are intermittent energy sources. Solar panels do not produce energy when the sun doesn't shine, and wind turbines do not produce energy when the wind doesn't blow. Excess energy generated during peak consumption must be stored to prevent wastage, allow for load balancing and minimise disruption. Safe and efficient energy storage still poses as a big challenge for engineers. Let's take a closer look at some of the most promising energy storage technologies. Pumped hydro storage accounts for 94% of global energy storage, often termed water batteries. These devices use gravity to generate electricity from water that has previously been pumped from a lower source to an upper reservoir. Perhaps a more modest example of renewable storage devices is the lithium iron phosphate batteries, such as those used by electric car giant Tesla. These batteries have higher energy density, are less hazardous to the environment, and do not catch fire, unlike lithium ion batteries. They can also achieve impressive efficiencies up to 92%.
There is a difference in what's needed for a mobile storage battery compared with a stationary storage battery. So if you take the example of an electric car, you want a battery that can allow your car to drive very fast. You also want it to charge up very, very quickly, so you're not waiting on the motorway to recharge your battery for very long. You also don't want it to be very heavy because you want a car to be able to move quickly without having to drag a very heavy battery along with it. And we use the terminology energy density to describe how much energy is stored within a battery per unit kilo.
I'm Richard, I'm the founder of Electric Classic Cars. We are essentially the largest converter of classic cars in the world to electric. And here in the workshop we have about 18 cars at the moment going through that process of converting them to electric. So what we have here is a really interesting project. This VW camper is actually going to go down to COP27 in Egypt later on this year, and it's a complete net zero journey that he's going to be doing in it. So he doesn't want to use any carbon-based fuels whatsoever. So he's going to be using pure renewable electricity to travel all the way from the UK to COP27 in Egypt. So we're converting this at the moment. We've got the gearbox out. We're going to put an electric motor onto that gearbox. And inside, we've already figured out where the batteries are going to go. So if you want to take a look inside, I can show you where the battery is going to go. It's a complete Tesla Model S 100 kilowatt hour battery pack we're putting in this, which should be around about 200-mile range. And because he's going to be living in it as well, it's really important to keep the internal space practical. So we've got a battery pack underneath here and a battery pack underneath the rear seat as well, which folds out as a bed. And we've even changed the gas cooker that was inside here to an electric cooker as well. So all of that will be powered off the big battery, and we've even got some solar panels on the roof as well to help with the journey.
Despite the current limitations, batteries have a huge amount to offer the net zero mission. For example, intelligent battery technology can coordinate the production, storage, and release of energy back onto the grid, playing a role in regulating and balancing energy supply. Hydrogen fuel cells are an attractive alternative to battery technology for electric vehicles because their only products are electricity, water, and heat. Landry Wales-based Riversimple is making an eco-car powered by a hydrogen fuel cell. In this technology, the hydrogen passes through a proton exchange membrane in the fuel cell where it combines with oxygen to form water and electricity. The electricity then flows to the motors in each wheel. These motors are small, lightweight, and give the car the four-wheel drive.
Hydrogen, it's element number 1 in the periodic table. It's the most abundant chemical in the universe. 75% of all matter is hydrogen, so it's out there, it's available. Our take on it, the hydrogen fuel cell, we use a particular hydrogen fuel cell that uses a pair of membranes, they're polymer, and where people are familiar with electrolyzing, we do the opposite with a fuel cell. We fire hydrogen at an anode and air on oxygen at a cathode. The anode will then split the hydrogen into protons and electrons. When that happens, you want the protons to go towards the cathode. They then rejoin with the air to form water and a bit of heat. But the bit that's really exciting is when you put the electrons out of it, we send them through another path and they output electricity. So clean energy split from the hydrogen element.
Whilst hydrogen fuel cells can only achieve suboptimal efficiencies of up to 60%, many would argue that this technology just needs a little more time in development to rival traditional batteries. We've learned about the different types of energy storage devices and how they could help cut the carbon footprint. But how badly is that affecting our planet? And how can we successfully capture carbon and use it to our benefit?
Carbon capture utilization, it's actually something extremely simple. So first of all, let's look at the words. Carbon, it's connected to carbon dioxide. So we are talking about capturing and using carbon dioxide. We know the reason of that. Carbon dioxide is causing global warming, and it's really necessary to capture CO2 and to put it to use. When we talk about carbon capture, what we are thinking is a system similar to a tree. A tree, for example, naturally under the sun through photosynthesis uses carbon and converts it into cellulose, into organic material. However, in chemical engineering, we do it with facilities like those behind me. So it's an engineering approach rather than a naturally based approach. So if you were standing in front of a carbon capture system at this very moment, you wouldn't be really excited. It would be probably a pipe made of metal, where, however, there is a lot of technology put into it. In the pipe, you have a material which is called a carbon dioxide adsorbent. It's just a sponge, okay? A very, very well-engineered sponge, able to separate CO2 from different gas streams, including air, for example. So in this pipe, you have entering an emission, which is a mixture of CO2 with other gases. It could be emission from a steel-making factory, for example.
There are currently 51 large-scale CCS facilities globally, from those still in development to some which are fully functioning. Carbon can also be reused instead of stored, be converted into plastics, concrete and biofuel.